Hello guys, this video is presented by Omkar Hasilkar, Shruti Pawar, Aditya Rabade, Malika Manir and Sarika Shedye. We are the students of Ashokrao Mane Institute of Pharmaceutical Sciences and Research, SAVE. This video is guided by Mr. A. Andage sir. In this video, we are going to see some previous year questions and their solution of subject Biopharmaceutics and Pharmacokinetics. Question: list USP in vitro dissolution test apparatus and illustrate any four apparatus. Answer: USP in vitro apparatus are of 7 types, that is rotating basket, rotating paddle, reciprocating cylinder, flow through cell, paddle over disc, cylinder and reciprocating disc apparatus. First, rotating basket apparatus. In this apparatus, rotating basket acts as a stirrer located in a cylindrical glass vessel with hemispherical bottom. This assembly is immersed in a water bath to maintain the temperature at 37 degrees Celsius. The most common rotating speed for the basket method is 100 rpm. Advantages of this method is used for testing immediate release and conventional dosage form. It consists of a wire mesh basket or a paddle blade immersed in the dissolution medium within a cylindrical vessel. Second, rotating paddle apparatus, similar to apparatus first but with the roles of the paddle and basket reversed. The paddle apparatus is typically used for conventional and immediate release dosage forms, while the basket apparatus is more suitable for extended release formulations and dosage forms prone to floating or adhering to vessel walls. Third, reciprocating cylinder apparatus. It is considered as the first line apparatus in product development of controlled release preparations. The assembly consists of a set of cylindrical vessels equipped with a reciprocating piston that creates a pulsatile flow of dissolution medium through the dosage form. It is used for testing transdermal patches, implants, and other dosage forms requiring continuous flow conditions. Advantages of this apparatus is it exposes the products to mechanical as well as variety of physiochemical conditions which may influence the release of products in the GI tract. This apparatus in the technically easy and problem-free use of test solutions with different pH values for each time interval. Fourth, flow-through cell apparatus. It consists of a reservoir for the dissolution medium and a pump that forces dissolution medium through the cell holding the test sample. This apparatus is of two types, open flow cell and closed flow cell. In open flow cell apparatus, this system has a configuration where fresh medium is pumped through the cell and the fractions are collected every 30 to 60 minutes, which result in rather high fraction volume. This is not practicable for the laboratory and therefore a volume splitting device splitter is used. Closed flow cell apparatus. This system has a configuration in which medium is pumped in circle and not replaced by fresh medium. Elute is collected in a beaker which is stirred by a magnetic stirrer. Readings can be taken online with spectrophotometer which measures the cumulative drug release. Advantages of this apparatus is open type flow cell offers the advantages of ability to change the pH conveniently during the test. Closed flow cell is used for drug products having very low dosage strength and essentially it can be performed with very small volumes. Question: compare active and passive transport of drug absorption mechanism. Active transport and passive transport. First point, energy requirement. Active transport requires energy expenditure by the cell, typically in the form of ATP, whereas passive transport does not require energy. Second, movement against concentration gradient. Active transport moves substances against their concentration gradient from an area of lower concentration to an area of higher concentration. Second, movement against concentration gradient. Passive transport moves substances along the concentration gradient from an area of higher concentration to an area of lower concentration. Third point, direction of movement. Active transport can move substances in the opposite direction of passive transport, allowing cells to accumulate molecules against their concentration gradient, whereas passive transport always occurs down the concentration gradient. Fourth, rate of transport. Active transport can maintain a constant rate of transport even when the concentration gradient is low, whereas passive transport slows down as the concentration gradient decreases. Fifth point, specificity. Active transport often involves carrier proteins or pumps that are specific to certain molecules or ions, whereas passive transport, particularly simple diffusion, is non-specific. Sixth, examples. Examples of active transport include sodium-potassium pump, which maintains ion gradient in cells, and transporters involved in the uptake of nutrients like glucose and amino acids, whereas examples of passive transport include simple diffusion or lipid-soluble molecules and facilitate diffusion through protein channels. Seventh, role in drug absorption. Active transport mechanisms play a significant role in the absorption of certain drugs across biological membranes, particularly in tissues with low drug permeability, where passive transport mechanisms are more relevant for drugs that can diffuse easily through membranes. Energy source. Active transport relies on cellular energy, mainly ATP, to drive the movement of substances, where passive transport relies solely on the kinetic energy of the molecules themselves. Ninth point, control process. Active transport is a highly regulated process often controlled by cellular signaling pathways, whereas passive transport occurs spontaneously based on the concentration gradient. 10th point, saturation kinetic. Active transport systems can exhibit saturation kinetics where the transport state reaches a maximum when all the carrier proteins are engaged, whereas passive transport typically follows linear kinetics. 11th point, requirement for carrier protein. Active transport requires carrier proteins or pumps embedded in the cell membrane, where passive transport can occur through simple diffusion or facilitated diffusion, which may or may not involve proteins. 12th point, biological cost. Active transport requires a biological cost in terms of energy expenditure, making it energetically more expensive for the cell, whereas passive transport which occurs spontaneously. Thank you guys.